So here's a quick video on how we do offsets in a Fanuc controller. I have a simple program set up, and I'm going to walk you through the start to finish. But basically, here's the program that I have. And as you can see, I'm gonna hold down Shift, and some of these I'm going to do on my keyboard, so you can see if you look closely on the Teach pendant, you can see what keys I'm pressing as I'm doing things. So just like so. Like Shift forward, for instance, if I hold Shift home, it goes through it on the Robo Guide. So if I hold down, if I just start my program, you can see that I'm going to do a simple program, basically making a triangle in space. Okay, fairly simple. By the way, that's a pause command, which requires you to hit start anytime you do it in production. Different than a wait, because a wait says stop, hold until something makes sense. Pause makes you have to hit start again. But there's my program, very simple. And in maybe we have a manufacturing environment where that's a weld or something, and just look in space. So we do it here, maybe make that little triangle, but we also need to do it over here. And we also need to do it over here. And as long as we know what frame we're in or what the measurement offsets are, then we don't have to reteach the points because it's all within the same setup. Or maybe we do something here and we want to go down and go down and go down. Instead of reteaching all those points, what we can do is put in an offset condition to allow the same basic shape, but then change it based upon the height or orientation. Okay? Which I will show. If you look on the screen, you can see what that command looks like. And if you take a look, this is the same exact positions that I just did, okay? Except it's 5, 6, 7, and 8. I could change those to 1, 2, 3, 4, and everything will work out fine. I just did a copy paste position, and the only thing different is I've added on the back end offset a position register with an offset condition. So if I click on this back end, you see the choice, and I can do well. On here, hit choice, you can see I can add an acceleration, a skip label, all these different conditions that I could add to the end of my job, okay? Vision offset, which we'll get to another time, but what I added was basically, and here's an offset position register. And if I highlight that, I can put in a position register myself. And I did 21. I don't, because why not, blackjack. So position register 21, and I added that to each one of my positions. And if I go into data and go make sure type position register, under position register 21, I can hit the position and you'll see, come on, enter. Oh, what did you do? Did you crash on me? There we go. Position. I manually entered in all these positions. Okay? 0, 0, 0, 0. And I'm just going to put in a 0 here just to demonstrate. So 0, 0, 0, 0. The other thing is I made sure I represented in Cartesian. If it's in Cartesian, it's going to be X, Y, Z, W, P, P0, all that fun stuff. If I go joint, then it's joint degrees. And just to give you some representation, in position register 1 or 20, I basically created an all 0 position so I can move the robot to an all 0 position, which you'll see in the beginning of. But that was all based on degrees of each joint. And you could do offset conditions in joint or Cartesian. So keep that in mind as you're doing offsets, that you realize which is what the application you need. So in here, I just put in all zeros. If I go back to my job, and if I run my job, shift home, you'll see it's the same exact job. Everything's hunky-dory, okay? But if I wanted to have that position register get adjusted, and I'm just going to I'm going to go back in. I'm going to directly put in a register value just to show you the proof of concept, okay? So I'm going to put in a -25 millimeters, okay? Now I hit done. We just ran that job. And I'm gonna run both jobs. I'm gonna get rid of the pause. I'm gonna, just so you can see both jobs in action. So now let me run this whole job. And you should see it went down. My robot went down. I'm gonna go through it again just so you can see. It's up, boom, down. Okay. So that's what an offset condition looks like. Well, that's well and good, but I manually entered that in. I don't want to pay someone to manually enter that in all the time. So what we can use is, remember register commands when we added and subtracted and all that fun stuff? We can do that with our offset condition as well. So I'm going to go in and I'm going to put in a jump label. Put in a label, and I'm going to call this label 2 just because. Down at the bottom, after it runs through, but on the outside of the label, I'm going to go in and put in an instruction. And under registers, here, notice under number 4, it says PRIJ. That's what I want to do, because what you'll see is the first number is the joint value. So if it's a 1 equals, for lack of a better word, X, 2 equals Y, 3 equals the Z offset, 4 equals, I'm gonna do roll X, which are y'all, 4, 5, and 6 are y'all pitch and roll, but I'm gonna just do roll Y across the Y axis. And then 6 are, be roll Z. So if you wanted to change your offset based upon one of those conditions, all you need to do is put the corresponding number in on the first part here. So that number here, and then the value here. So let me move this over here so you can see it better. Okay. Okay, so if I want to offset that height and do the exact same thing, that height condition, I want to do 3, and 3 enter, and say I want oh no, first sorry, I screwed up. This is first your position register. So position register 21. Now, and the second value is where I put the 3 in. Okay. Sorry, been a long day. So again, this number here goes in the second value. That's the J value. The I value is the position register. Brain fart, I apologize. Please ignore what I just said 5 seconds ago. But this is real life, so I'm not going to edit it out. But what this would do is if I run this line, and I'll show you. So I'm going to put in step mode. I'm going to do shift display so you can see it. Let me go to data. And see, right now you see the 25 right here, okay? See the 25? I'm gonna run this one line of code. And let me go back to done, and let me go back to position. And now look, it's a 0. Because once you run that one line of code, it's going to change it to whatever I want. So I'm going to go in here and put in like some random number, maybe like 1, 2, 3, 4, 5. Just humor me for a second. And now I'm going to run this one line of code. Shift, word. And let me go back over here. Let me hit done, position. And now look, hey, look, it just went in there. Imagine that. So say the first time through, I don't want to have any offset condition. Well, I want to make sure that's a 0. And by the way, you could, if you want to clear this out, you can either do it with 6 commands that look like this, or you have a known position register and set the position register equal to the 0, which I could show you. in a second. But so right now, if I run this job with, before you saw it clearly went down. Now if I run this job, because it's outside the jump label, I'm going to turn off step. You can see it's in the same place, the same location. Okay. So now, if I wanted to make it go down after I ran it through once, I could put in another register command and what we did before. Now let me, we have to do this way, 21, 3, and we want to do position register. As we would do an adder. So take the current value of the position register, and because I screwed up, let's do a negative 25. So why not? I could always go in here and do choice and change it to a negative and change this to a positive, which is probably what I should do. So now that's a little cleaner. So now, and then let me put my jump label back in. So now, as I run through this job, you should see that every time it runs this program, so no offset condition, offset condition. Now it's a jump up again. Look, it's going to go down further. And every time, and you can see it's going down, down, down. And I'm just going to go in here and take a look. I'm going to hit done. I'm going to look at this position and notice we've ran that thing 3 times and now it's negative 75. And I'm going to keep, but if I start over and run this job back again, you'll see it's going to start back to normal because I put a 0 in that position. And as I run the job, it's going down ever so often. It's going to keep on going and keep on going. Okay? Now I don't have to offset one condition. I can offset another condition. So let me go in here and I'm going to just change this. I'm going to go done. I'm going to go back to position. I'm going to put this at 0. Just to make sure. And I'm going to change the second value to a 4. And let's offset this by 25. Let's make that 0. And down here, let's just change both of these to 4. This should change the angle or the rotation based upon X. And let's see what this does. So normal. Notice oh, forgot to change one. Let's see what it does. So I go through it. Now look, it's going, look, it's at an angle now. And now it's at an angle again. Because I just offset that by that angle, and it's going to keep on going. So, and all I did was offset that by 25. Go back through it, let me do it again. I'm going to view this point here. But notice what the offset, because I saw the same shape is going through. So horizontal, now I've rotated. Let me slow that down so you can see it a little bit more. And you can see the positions have been offset by that angle. Now it's a limit error because I'm out of whack. So that's how you do position register. You can do position register math. Keep in mind too, if I was doing multiple offset conditions, So if I do register and say I want to set position register, 21 to position register 22, and if I go into 22, position, I can go in and hit 0, 0, 0, 0, 0. That could be just my normal position. Maybe a clear out for all the positions. So that if I'm doing multiple offset conditions or multiple things, I can just set a position register equal to another position register, and that helps clear out the whole thing. Okay. So that's how you can do math. And again, you can use your adder in there, say only do this 3 times or 4 times or whatever to keep something from resetting. The only other thing that I'm going to demonstrate, let me do a new job, create, and let's do recover. Keyboard. And yes, I should be putting frames. I should be putting in all this stuff. But let's say I'm running let's say I've crashed something. And let me go back to my other job, or let me just. I guess back into a normal convention. Okay. So say, I just crashed. Say I just crashed. Okay. So there I am, I'm crashed. All right, say I just crashed. Well, I can use something called LPAW. So if I have registers, say I have a position register, okay? Let me just do 23. LPAWS, JPAWS. LPAWS is like a Cartesian linear coordinate. JPAWS is the joint position. So say I have crashed my job, okay? And it could be anywhere. And just instead of trying to jog it out, what I could do is always set up a position register to say equal or your current linear position. And then I'm just going to kind of go here and do a point, just kind of put in linear. 20, let me do position register 23. And I'm gonna put an offset condition of 24. Let me go into here, done. Now there's a whole recovery program. I'm just using this for demonstration purposes. I wouldn't actually recommend doing this other than switching to tool mode and doing Z plus out. But here's this. And now what you can do is say, hey, move this position. And let's do jump label. All right, so now here's my recovery job. I'm going to function abort all and see what happens. Well, first I want to highlight this is our current position, and I'm going to go to world so you can see this is our current position. because I'm going to do this in step so you can see this. And let me go to edit. Oops. Edit. And I'm going to do step, forward through, and now notice I ran this job, position register 23 was not at the position, but now it is. And if I go here to data or enter, you'll see it should match my current position data. So just to show you, position, take a look. Everything is exactly, and it's even tool one, world, all that is there and good. So let me go out to back to my job. And now watch what happens. It moves up. If I run it again, it's going to move up more. And it's a way of doing a motion out by taking the current position and then going down. Pretty cool. The same offsets work with joint, the same offset. So you can do linear, but I like using linear because it's a straight line, makes sense. Joint just is kind of confusing because of all the angles. But the same principles apply. And I could have made this, I could have made this J-pause. But here's the issue. You got to make sure that your position, if I just run this position register, it may not always work out to your benefit because you have to make sure that this, so now this is all up. Let me go to 25. Let's go to 25 as my offset. I'm going to change the representation to joint and say yes, continue. And so now I'm going to just hit 0, 0, and let me just do negative 25 degrees on the one axis. In theory, the same thing should hold true. So let me go to J-pause because now I'm going to change this position to 25. Okay. And I can change this to a joint motion instead. You can see it just basically just did the one joint. So you can do, this is a way to maybe help change your configuration and joint motion, but notice those are the two ways you can do offsets. Programming is the exact same way. So I'm gonna go back to the program that I did, I think it was test 8, enter, and you can see what I did to set this up, okay? So it's important to know offsets because you can have a lot of fun with it. You can do some, and it saves you some, especially if you got something like advanced, it saves you some time. Now, if you're trying to palletize, there's actually a whole palletizing setup, which I might run through at some point when I have more time. All right, I hope this was helpful. Have a good day.